Unit 2, Lesson 2 continued. In this video, I will show you how to use unit analysis to convert each of the following. Now, the directions also say we will discuss how to go about shifting the decimal using the King-Hector saying above. King-Hector, sorry, I get that wrong every time. But that's what this video is all about. So there is a way to check your unit analysis work by just moving the decimal around if you memorize that King-Hector saying. And you can watch this video to determine how to do that. It is a quick way to do it. And I will even allow you to do this on your worksheets and on your quizzes and tests and midterm, but I'm going to do it in my videos using unit analysis because I think it will help strengthen our understanding of the unit analysis process. And if you're converting compound units or you're converting from one system to another, you've got to use unit analysis. So I think it's a good idea for you to practice with it as well because it will just help strengthen our ability to use that technique. But if you want to see how to use the moving the decimal way, you can watch this video. But I won't cover it in my own videos. All right, so let's look at example 1. In example 1, we're asked to convert 84 grams to, and what we're going to convert to in this example is kilograms. So we're going to identify our path. So what we want to do is look at our chart and see, do we have a conversion that will go straight from grams to kilograms? And we do right here. So we know 1 kilogram is equal to 1,000 grams. So our path is going to go from grams directly to kilograms, which means we'll only need 2 fractions and 1 conversion factor to complete this. The conversion factor, remember, a kilogram is bigger than a gram, so it's going to take more grams to give you 1 kilogram. So 1,000 grams is equal to 1 kilogram. And remember, if you're using this King-Hector to remember that, kilo is 3 steps away from the base, so it has 3 zeros. So that's where 1,000 comes from. All right, so our string is going to be this. Remember, you start with a given. This isn't a compound unit, so we'll just put it over 1. Our next fraction is where our conversion factor comes in. And we want grams to be on the bottom. So we have 1,000 grams and 1 kilogram up top. So remember, we want those grams on the bottom because we have grams up top in the first fraction, and that will allow us to cancel those units out. So now we do top times top, 84 times 1. Bottom times bottom, 1 times 1,000. And that gives us 84 over 1,000. And we're in kilograms. When you're working in the metric system, you want all of your final measurements to be in decimal form. That's the way we represent our numbers in the metric system. So you can use your calculator to do 84 divided by 1,000. However, remember that when we divide by powers of 10, we're going to move the decimal to the left the same number of zeros as what we're dividing by. So we have 84. Remember, the decimal is understood to be at the end if it's not written. We just don't normally put a decimal if it's at the end in our number. We're going to move it 3 places to the right, 1, 2, 3, which means we're going to need to add in a 0. So our final answer will be 0.084 kilograms. And it's a good habit to put this 0 in the front just to kind of sandwich that decimal point so you don't lose sight of it. Moving on to example 2, we'll get a little more involved in this one. In example 2, we're asked to go from decaliters, and this time we want to go to centiliters. All right, so we're going to start with decaliters. This one has the A in it, so it's the one that's bigger. So let's go to our conversion chart. And we're in capacity because we're in liters. It's not DL because it has an A in it. So this is the conversion factor we know, but that's only going to get us to liters. So now if we look down here, if we're going to centiliters and we know liters, we can use this one. So we're going to have to use two conversion factors to go from decaliters to liters, and then from liters to centiliters. All right, sorry I'm making you dizzy. Whoop. So with this example, we're going to go from decaliters to liters to centiliters. So that's going to take two conversion factors or three fractions. So the conversion factors we need are 1 deciliter is equal to 10 liters. Remember that D is one space away from the L, so we represent it with 10. Deca is bigger, so it gets the 1, and it's going to take more liters to give us 1 deciliter. Then for centiliters, we know that centi means 100. To determine whether 100 goes here or here, we think, well, what's bigger? A liter is bigger, so it gets the 1, and it takes 100 centiliters to give you 1 liter. All right, so those are our two puzzle pieces. So now we're going to do our string. We start with our given 0.0123 decaliters. Don't leave out that unit. That's what drives the rest of your work. This wasn't a compound unit or a compound fraction, so we're just going to put it over 1. We're going to have two fractions. What goes next has to have decaliters in it. So I'm going to use this puzzle piece. And where do I put decaliters? That's right, I'm going to put it in the bottom. So 1 deciliter is equal to 10 liters. So remember those alternating units. This is going to go next. It does have liters in it, so it will fit here. The liters are going to go on the bottom. So 1 liter, 100 centiliters. So now we see our deciliters will cancel. Our liters will cancel. And we're left with centiliters, which is what we were asked to find. So we know we're on the right track. This time we're going to be multiplying 0.0123 times 10 times 100, and on the bottom it's just 1 times 1 times 1, and that's centiliters. Now you can use your calculator to do this if you would like, but remember, multiplying by powers of 10 is going to move the decimal to the right the same number of zeros as you have in your powers of 10. So that means I'm going to take this decimal and I'm going to move it 3 places, 1, 2, 3, to the right. So 1, 2, 3. It ends up between the 2 and the 3. So my final answer would be 12.3, and those are centiliters. So there are some practice problems for you to try. So what I would like for you to do is try these practice problems on your own, and then we will discuss them in class. So try these on your own. All right, so that completes the first lesson. I will do another video with the part 2.